Everyone to be kindly be seated. The Company of Master Managers of India, known as CMMI. Today we are doing our annual seminar on the theme, Scaling Up the Maritime Sector in the World of Digitalization. While we have experts and many speakers, panelists, taking us throughout the day on the varied subjects. But to start the session, we have an inaugural session. And before I say anything, I would request our Deputy Master, Captain Pradhan, to please escort our designated DG on the stage, Mr. Shyam Jagannathan. A big round of applause, please. Captain Pradhan, sir, I humbly request to please honor Mr. Jagannathan with a bouquet of flower. And I will come for photograph. I would like to read out few lines with the permission of our designated DG, sir. Shri Shyam Jagannathan, IAS, officer from the Assam Meghalaya cadre, has been named the new Director General of Shipping, the nation's maritime administration, the Department of Personnel and Training, according to the recent release. Mr. Jagannathan is currently the Development Commissioner, Santa Cruz Exclusive Export Processing Zone and Special Economic Zone Mumbai, attached to the Department of Commerce. Under the Ministry of Commerce and Industry, Shri Jagannathan sir succeeds Mr. Rajiv Jalota, our current DG sir and Chairman of Mumbai Port, who has been officiating as the DG Shipping after the previous incumbent demitted office in the February of 28th. Mr. Jagannathan is on central deputation typically for 5 years from 31st of May 2021 and will have a 3-year tenure as DG Shipping. The new head of Indian Maritime Administration will be closely involved in navigating the government's plan to rewrite the Merchant Shipping Act 1958, as well as play a crucial role in taking up India's interest at the International Maritime Organization IMO on matters such as reducing shipping emissions to deal with climate change goals and the infrastructure technology which we are talking about today, digitalization. We welcome Shri Shyam Jagannathan, sir. I will humbly request Shri Shyam Jagannathan, sir, to say a few words, sir, on this auspicious occasion. Thank you, sir.
A very good morning, Captain Bhasin, Captain Pradhan, dignitaries of the stage, members, patrons of the Company of Master Mariners. Even though I have still not assumed charge of the office of the Director General, it's indeed a privilege to be here today amidst you. At the outset, being an officer from the Indian Administrative Service, the tag of a generalist stays with you. And I will really have to apply myself to do justice to what Captain Bhasin in the introduction mentioned as the head of the operational part of the Indian maritime sector. Our nation has a wonderful maritime tradition. There are speaking documents which have officially acknowledged the growth of the nation in this maritime sector. The Maritime India Vision 2030, wherein some of you would have been contributors to have shaped the document, lays out the broad contours. It's a trilogy of ports, shipping, waterways. At the core of it is a sector which perhaps has the highest economic returns, while it is confronted with across-domain challenges. The reductions in the carbon footprint, challenges of climate control, technology, and the ability for technology to disrupt. Now, these are the major strands I would want to engage with. Incidentally, coming from a background, I wouldn't take more time, but if you indulge me for another 2 odd minutes. My present assignment is as the Development Commissioner of SEEPS. It's a special economic zone, a very niche act, which looks at essentially a twofold approach to the national economy by promoting experts and generating employment. SEEPS is very near to the venue of this conference, Santa Cruz Electronics Export Processing Zone. Why I'm mentioning this is to flag off how a journey of an institution changes. What started off exclusively as an electronics processing zone with a very pioneering initiative then, because Kandla and SEEPS were the 2 pioneering economic processing zones in Asia. These then changed with 2005 as a Special Economic Zone Act. Yet today, the interesting part is, SEEPS is perhaps geospatially the highest concentration of gems and jewelry units. So it is 110 acres, which contributes more than 30,000 crores in exports. It would be quite interesting to dwell deeper in the sense the United States of America is the world's largest importer of jewelry. It's a niche segment where you have value addition. 25% of the global imports is from this 110 acres in Andheri. And a sister concern in Bandra Kurla, you must have been aware of it, the Bharat Diamond Bourse. It's close to around 20 acres. But the catch line they go by is, out of every 15 diamonds that are traded globally, 14 are traded through the Bharat Diamond Bourse in Bombay. So this was something I was closely working with for the last 2 years. We're coming out with a real cutting-edge piece of technology, the Mega Common Facility Center, which I would want some patrons to visit once it's commissioned by around September. Gives you a lot of cutting-edge technology in jewelry manufacturing, like 3D printing, casting, electro-refining. And it is a similar kind of a journey I would look forward to in my forthcoming assignment as DG Shipping. I would request the patrons here, stakeholders, I will keep the office as open and as easily contactable as possible. And I would request that you handhold, guide, and be part of the collaborative journey to take the maritime sector to higher glorious heights in the service of the nation. I thank the Company of Master Mariners of India for this brief opportunity and the interaction. And I wish you all the very best for the deliberations during the annual conference. Jai Hind.
Thank you, sir, for your kind words. You mentioned the roadmap ahead for you, and you took us to the journey of seats and your current position. But to go way forward, I will request our Deputy Master, Captain Pradhan, to please come here and give the opening remarks and take us through the CMMI and today's seminar. Captain Pradhan, sir.
Good morning. Shri Shyam Jagannath, IAS, I would call him the incoming Director General of Shipping, Secretary General of CMMI, Captain Bhasin, Treasurer of CMMI, Captain Gyanendra Singh, Chief Executive Officer, Captain Shashi Kumar, wardens forming the court of the CMMI, members, invited guests, and students. 54 master mariners serving in Indian ports, government, shipping companies, and ships at sea founded the Company of Master Mariners of India in 1956 on similar line and on similar aims and objects as the Honorary Company of Master Mariner of United Kingdom. The company was registered under the Companies Act 1956 on 23rd August 1957. Presently, the membership has crossed 3,800 and it's growing. Spread over 16 chapters all over India, plus 3 chapters abroad, 1 each in Singapore, Hong Kong, and Dubai. The representation of CMMI is not only pan-India, but it's also worldwide. A new chapter in UK is in the offing shortly. CMMI member base consists not only of sailing masters, but also master mariners who have taken up various show jobs and are today placed in top positions in the administration, fields of manning, training, port operations, pilotage, cargo handling, chartering, various agencies, management of logistics, inland depots, oil exploration, salvage, towage, you name it. CMMI members are everywhere. The CMMI court consists of 24 elected wardens, which the typical tenure of theirs will last for 2 years, after which there is a re-election and it rotates. The tenure of the current court will expire soon and elections are around the corner. I request all the members to exercise their voting rights during the upcoming elections, the schedule of which has already been put up on our CMMI website. In our efforts to ensure professional development of master mariners, we organize various seminars and meetings like this one, inviting some of our senior experts covering a wide variety of marine subjects and topics. To name a few, so far we have had seminars on the happenings at the IMO, the new ship designs, procedures for validation of expired COCs, deliberation on the Pollard Code for ships with transit through the North Pole, that is the Bering Sea, difficulties in implementation of the MLC, the requests from various companies, digital logbooks, hydrogen fuel of the future, cyber security, and a few more. With these far-reaching capabilities, CMMI has invited speakers from the administration of various maritime countries in the world, including US, UK, the Netherlands, Sweden, Hong Kong, Singapore, Australia. We have had all these people from the administration who participated in our meetings and shared their views and their process and their procedures with our administration. With the initiative of the government to promote port-led development, the activities in the field will only grow with time. Shipyards in India have already started producing commercial ships. Operation and management of such an industry needs to have a strong base. With this in mind, and in our efforts to enhance the professional knowledge of master mariners, we have recently signed a MOU with the National Institute of Industrial Engineering, NITI, to start a special executive MBA program for seafarers. covering various marine subjects. I would like to request one of our members a little later to give us a little more insight into this upcoming project. Our Extra Masters course is already popular among the industry, with a large number of candidates taking benefit of this program conducted by CMMI. We also conducted a certificate course with the Institute of Directors, certifying our marine master mariners into becoming directors of companies, some of which you are like to lead in the future, some of the students sitting behind here. So make use of these projects which are offered by CMMI. CMMI, along with the Institute of Marine Engineers, have jointly been running a board of examination of seafarers, where we conduct exams of young boys who do their pre-sea training. The exams and certification is done by Board of Examination of Seafarers under the guidance of CMMI and IME. Mentoring of cadets is yet another project which has met astounding success. Master mariners and members of CMMI are assigned 1 or 2 cadets from the industry, and they are mentored. The success of this program can be seen from the feedback of the cadets who are the mentees. Such mentoring builds up a platform for these young little boys to grow in their career, in which our Prime Minister Narendra Modi says, sky is not the limit. CMM has also collaborated with the Indian Maritime University to set up a research policy cell. We have nominated one of our members to coordinate closely with this project. Our today's seminar is aimed at discussing the various aspects of autonomous shipping. How we can upskill today's, let's say, second officer, a second mate, to man tomorrow's ships. The seed for this was sown by none other than our immediate past Director General, Mr. Amitabh Kumar. Mr. Amitabh had personally called up Captain Jha, our master. By the way, Captain Jha is not here today because he is not well. He is not keeping well. He has undergone some procedure and he is still recovering. Otherwise, this seminar has been very close to his chest and he wanted to participate. But unfortunately, the medical advice doesn't permit him to do so. As a seafarer supplying nation of the world, we need to understand the future requirements of this industry. We need to upskill our current workforce to command the future of shipping, be it navigating ships, sitting remotely, or carrying out maintenance from remote locations. Research is already on at the IMO, where experts are presenting papers and suggestions and to make changes in the STCW convention for qualification and certification of future seafarers. By the end of the day today, we expect to prepare a white paper on what India should do to adopt the system to sync up with the future of shipping. That's the main focus and the objective of this seminar. And to do this, we have lined up a galaxy of speakers sitting here, from India as well as abroad. Especially I must mention Mr. Lars Lipuna, who's come all the way from UK, and he's going to address us during one of the sessions. Of course, though it may not be possible to be very comprehensive in this subject right now, and we cannot cover everything in this direction, we are happy that we are taking baby steps to start and taking an initiative to start this. And I'm sure in future coming days, this will only grow. With this, my friend, I declare this seminar open, and I request our learned speakers to hand over the further proceedings to our Secretary General, Captain Bhasin.
Thank you, Captain Pradhan. We have one more short things to do. We have a book written by a master mariner, which is very befitting our today's topic and theme. I would request Mr. Ashok Advani from the Sagar Sandesh, who is publishing this book and promoting, to please come on the stage and speak few things before we request Shri Shyam Jagannathan to release the book. Mr. Ashok Advani, sir.
Thank you, Captain Bhasin. Very good morning to everybody. Good morning, my dear. That's it. The book covers maritime skills on vessels and shore with STCW convention, relevance, and recommendations. The authors of various chapters in this comprehensive book, what you will see, come from wide variety of maritime organizations, CEOs, directors, professors, researchers, and seagoing on-shore maritime professionals in the global maritime industry. The book is co-authored and edited by Dr. Captain Vivek Jain. I'm sure a lot of master mariners will know him, but let me give a few lines on him. Versatile and multi-skilled Dr. Captain Vivek Jain is a barrister in England and Wales, master mariner with PhD, LLB, LLM, MBA from Norway, and of course, CMMI member. And he is the author of 3 scholarly books on law. And now you see him as a prime mover for this new project on maritime skills. How coincident it matches with the wonderful theme of CMMI on an annual day. Captain Vivek is currently a director of marine services of a renowned firm in Singapore, ALCO, where he handles and pursues commercial and maritime international arbitrations in various international forums. About the book, few lines. The book provides an overview and analysis of the skill required for different maritime operations and management systems. It also fills a need in providing solutions through various options and examples of many issues and concerns. The subjects covered include skill requirements supporting women's empowerment, driving innovations and adaptability, understanding of financial management, human rights and relevant insurance and self-protections, behavioral skills, mental health skills, control and automation, digital skills, security skills, knowledge of LNG fuel vessels, the most wanted topic, simulations and workshop in training, along with future shore jobs in marine pilots, marine surveyors, marine managers, DPA, marine superintendents, and so on and so forth. I now request Captain MP Bhasin, Secretary General of CMMI, to take forward the launching of the book. Captain Bhasin.
Thank you. I request Captain Pradhan to please hand over a memento to our designated DG, sir. Thank you, sir. That concludes our inaugural session. I would like to propose a vote of thanks to Shri Shyam Jagannathan ji, our master, our deputy master, our wardens, and especially all the attendees and dignitaries over here today. We look forward to our whole day-long session with esteemed speakers and panelists. And I close this inauguration now. Thank you so much. Request Captain Pradhan to please take the sir on the dais. Sudhi, clear the things. I have a small role to play, just to invite our first session moderator and the chair, Captain S. Kishore, an extra masterminder with over 45 years of experience in both maritime and allied field, mainly in senior level shore-based position in India and abroad. He retired as managing director of Kongsberg Digital in 2000, a 210-year-old MNC. Presently, he is a professor of practice with the Indian Maritime University, IMU, reliving his passion for sharing knowledge. Captain S. Kishore, we welcome you on the dais, please. He'll be our session chair and moderator. And I will quietly sit down and watch the proceedings. Thank you, Captain Kishore, sir.
Thank you very much, Captain Bazin. Friends, colleagues, and the fellow seafarers from across. First of all, I should start by saying that we follow the tradition of IST, Indian Stretchable Time, just about 40 minutes late. That's okay. What's 40 minutes between friends? So I think I will say that the session, which was supposed to last for 90 minutes, will now be cut down to maybe 75 minutes, and request my rest of the session chairmen to sacrifice a little bit here and there, and we'll make it happen. Having said that, gentlemen, takes me back to the time in the mid-70s when many of us went out to sea when we joined the ship. And then we had this typical concept of a wheelhouse, so beautiful to walk around. We had one central console, a steering console, and then we had a nice chart room. You entered the wheelhouse from the chart room. You had nothing else. You had a coffee table on the left-hand side, and there used to be something which is round with an inverted funnel on top of it. We used to call it radar. And I remember that time also, in the early days, when the masters used to lock the radar. I'm not joking. Radar is not for the cadets. Radar is not for junior officers. It's only for the master and maybe chief officer if he is senior enough. Those were the days. Of course, we didn't skill up then. And then we kept watch. We used to go after the watch, back to the stern, read our patent log, and we used to be so happy we found the speed of the ship. And then we used to come back closer to the shore. We used to drop our lead to find out what is the sounding and so on and so forth. And then these moved on. As we moved on, came in the Doppler log, which gave us speed. We got few more things added, and these inverted funnels came on both sides. They called it X-band and S-band. And yes, now we were allowed to use the radar. So we skilled up. So we skilled up to do the radar and ARPA course, which is true. Every one of us, our first certificate Coming back, the word used in my this thing by Captain Basin is reliving my passion of sharing whatever I have learned in this life back to the children at large. Coming back, one thing I do want to very clearly state that the passage of time that we have gone through during this movement from that period when we had these two radars to now is been phenomenal. And so is the world. Mind you, at that time, even the education sector was so simple. We had 5 or 6 disciplines in engineering. That's it. Nothing more than that. An electrical, an electronics, a mechanical, a civil. Incidentally, I don't know if you all know, why was civil called a civil engineering? It seems in the earlier times, during the second industrial revolution, every other engineerings were defense. Only the construction of houses and things were civil. So it was called civil engineering, incidentally. I was surprised to find that, but that's true. But then we moved along, and we skilled up, and we skilled up. And then came a time when, thanks to the skilling up, the coming in of the GPS and DMDSs, and then the first thing that came in was SATCOM. I remember in the 80s, we were so happy, we're getting positions every 2 hours, yeah, can't believe it. Gone are the days of sight. But yes, we used to take the sight, and we were never believing that SATCOM. We believed our sight more. Like the early days of IGDIS, we believed in the paper chart more, including the courts said, we don't accept IGDIS. And we skilled up again towards these new technologies that come in. When we skilled up, the sector saw the need not to have a radio officer, maybe. The first one to go for the so-called pursers and immigration clerks. Then the radio officer wasn't fitting into this beautiful camaraderie or beautiful family on the ship. We used to have electrical officers, wireman, pursers, immigration clerks. Those youngsters who don't know it, electrical officers were called Batti Saab. And the wireman was called Mombatti. Those were the days. And then we saw it fit to why not merge these two together, the radio officers and electrical officers. So we came up with something called as possibly the electro-technical officer or whatever it is called now, but I know it in short as ETO. We love abbreviations in the technology sector, you know. So we will stick to abbreviations so that I don't make a mistake about the expansion. Vaishak will correct me maybe. So anyway, coming back to that, when these came in, so is the education sector. By that time, the world at large has already moved into third industrial revolution, gentlemen. Computing power had started moving into this world to such a level that suddenly these 5 or 6 simple engineering disciplines made 20, 30 various engineering, mechatronics, electromechanics, whatnot. And then, of course, the so-called computer engineering, computer science. Within the computer, there are 10 other disciplines, and all those came in. Things are moving very, very fast. Controllers started coming in initially into the engine room, then onto the bridge. The so-called bridge has now become a nice place with a lot of gadgets. It has become almost like a cockpit. Everything connected together. Chart room vanished. We don't need it. We can be keeping it anywhere else. And now I believe Admiralty has stopped printing paper charts. We are in the days of IGDIS. We got all the system coming together in a single module, commonly called as a system integration module, possibly, which is giving. But what the technology did was convert the data that we got. Mind you, we are today in the 4th industrial revolution where data is the king. We are converting the data into information and information into knowledge. Maybe it is that knowledge that is given as a display to this human being on board the ship, even now. The human being on board the ship to take informed decision. Have we got safer because of all this movement? Maybe yes. Does the statistics say so? In the unstretchable time, maybe. Statistics say so or not, but we are positively taking safer decisions. There is no two ways about it. Technology is not difficult, gentlemen. It's extremely user-friendly. Do not be afraid of technology. I moved into a technological space at quite an, ripe age, if I may say, because I never grow old. I'm still young, of course. So at a riper old age, possibly in 2004-05, and I can tell you, it's very, very simple and user-friendly. Let's not make technology use you, but you use technology. With that said, it is into this era of when the education at large changed from mechatronics and electromechanics to more focused industrial automation, industrial electronics, and so on and so forth. And into this era was born our first speaker. Let me introduce Mr. Vaishak Chavan, an extremely talented human. I know it because I know him personally right from the day he came out to sea in 1994 to the time he stepped ashore with executive ship management in 2002, if I'm not mistaken, and joining on into Anglo-Eastern in 2009. I mean, he's an absolutely multi-talented and multitasking guy. Multi-talented to the extent that if he wants to learn something, he goes deep down to it. I remember when the Eastern Freeway was built, when it was built, he got up at 2 in the morning just to see how these two girders are being connected. Pagal hai kya? I would have rather enjoyed my dream here. But no, this guy will get up, go there, watch, and next day he will tell all of us, hey, this is the way it was built. So that good a teacher he is. You know, he will tell us next day, so we learn from him. Let him do all the hard work. Coming back to that, Vaishak Chavan is ETO, who's been practicing, maybe I would say he's one of the first electrotechnical officers, superintendents coming ashore, I would say. Presently with Anglo-Eastern as head of projects, has done a lot of projects. I don't know how to get deeper than that, but he will be our first speaker, taking us on from the days of relays to PLCs, programmable logic controllers, to distributed control systems, and how is it that we, as the users, could become super users to take maximum optimization out of the technology available to us. And my second speaker, going on from there, is Captain Gaurav Manjal. He is another master mariner. He's a BSc Nautical Science from Chanakya, who came ashore to join ARI. And I recall that when he joined ARI, he said, if you're going to call me for teaching or anything of that sort, I'm not interested. I want to go into simulation. So he's a man whose passion is simulation. And it is that passion that is going to, with that, he is going to take us through the passage of how the technology has taken over our world, moving towards a vendor-neutral, integrated bridge system, which is the harbinger for our later autonomous ships. They're very simple. Mass degree 1, 2, 3, 4 is very simple. But all of you, for the sake of remembering, remember that mass degrees 1, 2, 3, 4 can be used by a shipowner in a single voyage. And that needs to be understood because that's how the shipowner is going to use it. With that, let me invite the two speakers onto the stage and I shall get down. Vaishak and Gaurav.
Yeah. Good morning. Good morning, everybody. Very distinguished audience. Pleasure to be here. And thank you, Captain Kishore, for that introduction. Leaves a lot unsaid and a lot said. So without much ado, I think we'll start. I know we're running short on time. I'm going to try and walk us through this as quickly as possible with as little pain as possible. Please bear with me. All right. So when I was told to take a look at this session, it kind of dawned upon me that it's been a long time that I've been out to a ship. And this is what we are doing today, okay? So take notes, right? But this is just an insight into my crazy world of things that I have to deal with, and so does the automation world. So I just wanted to scare you a little bit with that image. But we'll move on from here, and let's talk a little bit about this. I come from a world where I even did my radio officer's course, so I dealt with valves, you know, so having to wire together valves, and I'm a musician, so I like to build my valve-based guitar amplifier, right? So I come from that world, and it's no surprise that all of this that you see on the screen has been relevant and bearing upon the outcome of where marine automation is today. And I think we are in a transient phase at best, and things are going to change way beyond what we can fathom and see at this stage. So just to get a little technical, I'll skip the initial parts, but from the point, I first went out to sea, and when you go out on a new ship, you're pretty much useless. You can hardly find your way around. So I was given the control box for the gantry crane to pick up provisions. And whilst I was doing that, I realized that this thing had a joystick. And when you moved it a little bit, the speed of the crane changed. And this was way back, right? And I think in the early 90s. And I was damn excited about this. It's a new ship. And I went around telling everybody, hey, look, this has got speed control and stuff like that, right? So they all started looking at me like this, like, so got some defective material on board already. Yeah? But anyway, moving on from that world of speed control, microprocessors, and automation, a lot of things have changed since. And they have changed primarily because of the computing power of the microprocessor and of software. So today we are in a world of implied automation, but I'm going to try and walk you through what we thought the scene was and perhaps what areas we were looking at. So as an ETO out at sea, this was my primary business. I looked at power and machine control, so just to give you this very distinguished audience once again, a little rundown on how it all happened. We still have our own problems with managing power and producing displacement of the vessel, by which I mean the main engine. For me, the heart of it all, from my perspective, is definitely the instrumentation world and the alarm monitoring world. So we've come from this world where I see these as the various segments of competency, if you will. And when we're talking about skilling today, so when we're talking about skilling, it is necessary that our students are familiar with these areas as a minimum standard. There's a lot more to go on, but this is the minimum standard. What you see on the bottom right, of course, are the areas which require this kind of modern instrumentation and system automation. So I'm sure we're all familiar with this, but this is just a cursory slide. Let's move on. I still believe that we still don't utilize the resources that we already have at our disposal. This is just one example that I've taken out here. And I was on board a vessel, and this particular autopilot, I don't remember what the make was, but it had a button there. It said PID, which is obviously proportional, integral, and derivative control. And there was another button which said MPC. Any takers? This was about 10 years back. So MPC is an option that was provided on this rather new ship. It's called Model Predictive Control, 10 years back, right? So it's a far more efficient way of navigating the vessel, right? And reduces the deviation that you would see on the course recorder by an enormous amount. 10 years back. So I was very keen to figure out how it worked, and I asked, hey guys, do you use this? They said, no, we don't ever touch that button, right? So in fact, strict orders to stay away from that button. So much for model predictive control. But the point that I'm trying to say here is, or make here is, that there are a lot of technologies already available, even on legacy-based systems, that we have yet to dive into, and we are probably just about getting there and starting to integrate this into various solutions. And I can think of dime a dozen such solutions that immediately come to my mind and can help assist the whole process of running the ship. Here are some of them. I'm going to keep this session as short as possible. I know we are pressed for time. But a few that come to my mind are, typically a vessel goes through what I call certain states. So this is adapting from a controls perspective, something that I call state machine control. So I do believe that there is enough intelligence already on board to be able to detect presently what state the vessel is in, and possibly create local dashboards or information points for the consumers, by which I mean the operating personnel. So that's something that we are looking at, is very, very interesting. It's happening ashore, it's happening with fleet performance centers, but I think that information could also come back from the fleet performance centers and localize it to generate a far more interactive approach with your machines. For example, there's certain information that are not immediately apparent to the operators, but through this so-called implied intelligence, it'll reveal a lot more. So this has got to do a lot with our software world, with data sets, possibly with model predictive control and approaches like that. But surely this is on the charts. So more? Yeah, I think there's lots more. So having, kind of touched upon this a little bit, what hasn't changed, of course, is the competent seafarer still has to go through the rigmarole and the grind of being sure about in these areas, safety shutdown systems. Sorry, I'm getting a little techie here, but irrespective of what happens, the safety shutdown system is paramount. You cannot get a remote safety shutdown. It's still got to work hardwired in a fail-safe manner. So just a little point in case here, things have changed even around that world, right? Because you have programmable logic controllers supervising the system, it is possible the computer within that system can also hang and go to some state. So for that purpose, if you have an emergency shutdown system or something that drives an emergency shutdown system operating through that mechanism, it's going to fail. So now we've had to rewire the entire solution through what we call, sorry gentlemen and ladies, a safety indicating relay system, right? That's hardwired into the process. So we have made systematic changes into how we do business out at sea, and that trend continues to happen. One very interesting area is of alarm monitoring systems. The name says it's an alarm monitoring system, and it's got nothing to do with the control process of a ship. There's just been one ship that I know of wherein the alarm monitoring system was connected to the safety shutdown system. But this is huge. Today, while we're trying to get our machinery data ashore to assist in the whole process of being able to meter what's happening and compare the ship's performance against standards, machinery standards, as well as its own historical trends, we are trying to get and extract data from these machines and bring that data ashore. It's an absolute nightmare. It's mayhem out there. And the reason for this mayhem is something that's a spillover from the past. There are standards. And they say, the good thing about standards is that there are so many to choose from. So we have different companies kind of bringing in their own solutions, picking up data from machines as well as from the wheelhouse, and now bringing this data into a data set 1. You can overlay a data set 2 upon that, which is not native to the ship, which belongs to possibly location and geographic information. It could relate to the mathematical models of what the machinery is, or it could even relate to sister vessels and what their trends offer. So this is what we know, this is what we are doing today. So, that's a very, very interesting area. Let's move on. Okay, so this was on the to-do list, just to introduce you to what happened out at sea. My first tanker vessel, and I was told that the heart of the vessel is the boiler. So you are supposed to take a look at the boiler control system. So you probably went on board as engineers and as electricians like myself. You open the boiler mechanism, and you saw this whole array of relays which went clackety-clack, right? And then very carefully you closed it and crossed your finger that the next time the boiler had to fire, it would actually work, right? So that's relay-based logic, pretty much an ancient thing, but still available on board, and we will still carry it for time immemorial because that's your final barrier. No matter what, that relay-based logic system is not going to go away. So yeah, it's a nightmare in vanilla, as I call it. Then we moved on to special purpose circuit boards. A lot of electronics started happening on board, and companies started customizing electronics for special situations. Captain Kishore worked with Kongsberg, and I would die to work with a company called Nor Control, which is part of Kongsberg, and they specialized in this, and they still do. Moving on comes the world of programmable logic controllers, where we are today. Very, very interesting, still out there. It drives people crazy, but the whole point of having programmable controllers was to make the troubleshooting approach easier, right? And we still use it primarily for sequential control and control for machine. But there's a lot more that the PLC world can offer, and we are starting to see that today. And then, of course, we have these SCADA systems, which kind of decentralize information and can bring it to various layers, permitting you to do what you will with it, right? So, however, what we have in gray, intentionally in gray, is what's barely readable on the screen, but if I could It says distributed control, IoT-based system, and implied control. That's where we are today, and I think that's where the world is going, trying to get in more sensors on board so that we can get more information out of systems, and we can use that information systems to create more complex data sets and query those data sets more intelligently to get results that we didn't know that we had access to. That sounds a lot of jargon there, but excuse me for that. That's my world. So yeah, so this looks like another horror story in the making, huh? But I assure you it's not. It's there to make your life a little simpler, or so we hope. All right, so I was also told to mention briefly what these PLCs are. That's what comes to my mind when I think of a PLC. And we don't really need to get too much into the details, but making a point that I made earlier, or coming back to that point, is these things are now changing. These devices are hosting web servers. They're hosting web servers, imagine. So you have information inside of a machine which is being displayed on possibly your browser or on some other system. And today's programmers can do magic with that, bring that information out on different levels, provide you with different access controls, right? So there's a whole lot of possibilities happening with what we have existing on our ships right now. We don't really need a brand new ship to get it all going. You can surely extract information, and that's what we're doing today. So yeah, there are pros, there are cons, but I see a lot of that happening here. I'm a slide actually behind. Yeah, so that's what I was mentioning. This is important stuff. I mean, I think a lot of our machines and our supervisory systems could do with extracting that information and do a lot more than we already do. The whole point of these systems is they even provide you with access control. That means you can throw a switch out at sea. So for the people who want to flag up and say, I've got a cyber security issue here, I'm not going to allow access, right? We can permit that access through different systems, and we can get special services activated on existing machinery, allowing you to interrogate that system and possibly create more information possibilities. So we call that dial and logistic support. It's been around for some time, but today it's changed fundamentally because we use that to associate it with possibly interconnected systems and get new results. So this is, again, my world. Sounds a little crazy. Now, the thing is, the reason why this world has changed a little bit more is more to do with the open source industry, or rather, not really an industry, but the open source community, right? These things have really taken the world by storm, and it is the open source community that has driven what we call today the IoT world. No surprises there, right? I come from a community. In fact, just about a few days back, I still program microcontrollers. I still do embedded systems. And I'm happy to announce to you that I was able to successfully prompt ChatGPT to write code for me. And I did that successfully. All I had to do was to take that code and push it on the machine, right? So things are really, really changing. And it worked. The damn thing worked. It's incredible. So because this open source community is so flexible in its approach, seamless almost, they bring out new possibilities, I think. And they bring out a lot of utilities which we can help to create new things. So some of them are listed out for those of you who follow this stuff. Those protocols there are making a lot of sense. We do have distributed control system. Kongsberg has a few, and Terasaki too. There's so many dime a dozen players. But what we are missing out from the standard stuff that we have here is the ability to integrate within that system and to get the data out. What you do with the data is what makes it most interesting. The data by itself has got no meaning. But if you can have pattern recognition, if you can compare this against test performances, or you could compare them, like I said earlier, with previous historical data, deviations and stuff like that, then we can get a whole lot of stuff going on. This is the machinery world. I'm talking about the machinery world. Similarly, you could apply, sorry about that, that's the alarm. Yeah, but similarly, you could apply that same idea to what is now required in this world. It's called edge computing. I'm sure a lot of people here are already familiar with this term, but this basically means taking this new implied automation that you want and pushing that computing power on the edge where the information is first received. So if you process that information on the edge, then you kind of save yourself the botheration of bringing that data ashore, working on that data, and then getting new results. So a lot of that edge computing solutions, it's a generic word, it's used very loosely, is creating newer possibilities. That's the place where you could possibly have new queries into systems, allowing you to say that this is the state of the vessel, and the last time you were in port and you were pushing out cargo, or you were moving into a certain channel or a certain canal, this is what you did, but this is what you're doing today. You know, you could possibly have a worm wheel like you have in a cricket match, saying this is your run rate required and this is where you are. So it's a guided path to a very dedicated process. Immense possibility. Industry is already doing this in production areas, and it's mind-boggling to see those results, right? They can pick out operator efficiency. They can tell you that I've got material stockpiling. They can tell you I've got inefficient use of energy. So all those possibilities are just now migrating onto our world, and we should lap it up. So I'm just going to talk a little bit about this. We have all these kind of possibilities happening here, and I think multiple vendors are struggling to actually make this happen, right? So fuel efficiency, of course, is happening. We are tracking these vessels. We are able to put them up on screens. We are able to even give services to the managers saying that I want my vessel to go from here to here, give me an optimized path. I have some wonderful use cases after this, which gives us an insight into how that happens. But this is what's happening right now. Yes, that last line there is hopefully where we're headed. And I just finished a little workshop on AI. So the first thing that the gentleman said is that it's not AI that's going to take our job. It's the people who can use AI who are going to be able to use it differently to create new requirements and new solutions in your present industry. So the domain knowledge that we have is not going away, and it's just going to integrate into what we already know. This is a little snapshot of what we do currently. So imagine we've got a team of people sitting back here in the office, monitoring, looking at data. We're not in autonomy mode. We're monitoring, looking at data. But you're using that database very effectively, writing out queries, possibly using tools like Power BI and NVAS and stuff like that, to be able to help them to recognize patterns. Another interesting possibility that's happening is when you don't have data, you can use things like what we call a SMOT model and generate more data to be able to create a fingerprint of a process or something related to a machinery profile. And you can integrate or you can overlay the existing data on top of that and then create magic of saying that, I think you've been pushing this pump too hard, or I think you've got too much ballast in tank number 7. Right? Sounds weird, but it's there. It's happening. So, right, so of course, I'm sure we all know about fuel optimization and things that are happening with all this kind of data. A little bit of the old school NMEA standards, where we're looking at data exchanges for bridge machinery. This is a little interesting slide because most of the industry or most of the people, the vendors who are trying to automate ships and get the data here are looking at wired systems. But there are a few people who made an early start who are exchanging data wirelessly in a reliable manner. This is just a little insight into that. Right? So they have mesh networks already deployed, being able to successfully pull out temperature and humidity in this case. But most importantly, you even got an indicator for your battery health and for your signal. So there's a lot more. It's easier deployment, faster deployment, and more possibilities. You can push these sensors very quickly, possibly in a day, maybe in your forecastle, yeah, maybe on deck into your machinery, as well as accelerometers on the bridge. So no real struggle when it comes to sensor up the systems. Okay, I'm going to move on a little quickly. I think I may be pushing time here. But yes, a lot of interesting things happening here with the FOSS system that's on offer by Wärtsilä. There are others. Some screenshots. But I will quickly try and move on into That's the kind of results that we are getting right now. And there's a long way to go. These are dashboards. These dashboards, of course, only information dashboards. But like I said, the query system that requires us to go into making intelligent, dynamic decisions for control, real time, ain't happening yet. Yeah, but I'm sure it will. I'm sure it will. Right now, there's a layer in between that's still doing this task for us, but I'm sure those decisions can be made, can be automated, especially with AI running the roost now. So some sample reports gives you absolutely brilliant insights, but like they said, there are three kinds of lies: lies, damn lies, and statistics, right? So we tend to pick and choose only what makes sense to us, but there's a lot more there that can help to bring out problems. Highlighting some of these problems. So here's a little analysis of the SFOC shop trial, what the problem was and how it was adjusted. So fuel safe. So we already are looking at getting solutions out of investing in this kind of technology, not directly plugged into the system, information not directly available to the operators or to the supervisors, right? Happening presently to the FPC. Another use case, route optimization. This is fantastic. I mean, this one is great, but I think I have another one, and I possibly think, I don't know whether I have it in this presentation, where they, things of old, where you could use the current and the drift and a timeline and be able to get the displacement right on time or just in time there using these new patterns. And we've actually seen that done, so use case. Trim optimization. Recently on a vessel where we deployed, measuring the draft in a very, very different manner and taking that information and feeding it into the loading computer, right? The end result was you could even pick up, and we've actually built a system like this in the training center too, you could eventually even pick up or preempt parametric rolling and synchronous rolling, I think is what you call it, right? But this is huge. I think it has got tremendous possibilities in being able to tell you how the vessel is moving based upon what its presence dynamics are. So that's another kind of untapped area that I think will start to make a lot more sense. Yeah, this is the problem. The problem is a lot of the information that comes to us is coming through static data templates, through noon chits and reports, and when we feed that back into the system, it's prone to errors. So the struggle today is to be able to make this information transfer dynamic, real, and through instrumentation, rather not rely on noon chits and reports and the man in the middle. So we are there. Right, coming back to the main session stay today is what are the challenges when it comes to training and skilling up people. I think there's a huge gap, and I think we all agree that there is a gap, and we need to close that gap. So I'll just leave that there for you all to take a brief look at. But I know we are starting out a few courses, and those courses are going to be a little difficult, a little bit of a struggle, but we're talking about software integration for different ranks, and to try and be able to work your way around with computers, with networks, with information exchange, to be able to reconfigure a white switch, if you will, right? So that's the big gap that I see in skilling. Another big gap that I see is the fact that we do not have a multi-domain approach. I don't think we can restrict ourselves to our primary area of competency anymore. We must and we have to be able to look on the other side, and it's no big deal today to be dipping into the technical box or some other kind of, possibly even the software box, because like it or not, is the domain knowledge is always going to drive these things. It's only going to help you magnify what the possibilities are. Right, so we have a few of these things. I'm sure most companies have something that we call a shipboard operating environment as a starter for a course meant for seafarers, my young friends there, which will help them align their competency with what the company is offering in terms of a monitoring solution. So that's one bridge that's already being built, but I think a few more bridges need to be built. Networking skills and awareness to protocols is a huge challenge. Today, we have to send technicians on board, the cost is high, but once we can kind of somehow strategize that in a very predictable manner, I think we'll get a lot more done. I see a time horizon of about 5 years for this, and keeping my fingers crossed that that will bring a lot more data for us to manage and to be able to get stuff done. So what you see on the right are some more protocols, just to flash them there for a few of my friends who are into this kind of stuff. That's all I have to say for right now. Thank you very much. And if there are any questions, I'm willing to take them.
Thank you, Vaishak. That was excellent. I was just thinking, the first time when the so-called IT came into our world, first thing we all thought it's income tax. Yaar, koi piche aa raha hai apne piche. Till we came to know it is something called as informational technology. If I have to look at IoT, Panda will tell me Indian Ocean Tribunal or something like that. Now we know that it is Internet of Things. The point is that it's not difficult, though it looks to be a lot of jargon. Yes, he got the jargon alarm, which was very important. It is not a big jargon. I remember getting into this industry when I was hearing all this jargon. The first thing I asked the set of youngsters, do you know what is an EPUB? Everybody was looking at me. I said, that's it here. If you're using a jargon, make sure that you expand it. So that's the kind of possible little bit of a gap that we need to fill up. But I again repeat, do not fear technology. It's extremely easy. We just have to take the first step. One living example is this and banking. I do all my banking in this. All of you can. Having said that, let's see the answer to his questions or the way forward to from the path that he has defined. We have Captain Gaurav Bajaj. I think he will be able to tell us what is he going to do with this training.
Thank you. Good morning, gentlemen. Thank you, Captain Kishore, for a lovely introduction. Thank you, CMMI, Captain Bhasin, Captain Pradhan, respected guests. And more than that, thank you for actually giving me a topic which is very close to my heart. So all these things about what we talked about, IoT, AI, all these jargons is something which can be a wow factor for someone and which can be an interesting factor for someone else. So, but yeah, this is it. I mean, it is there to come. It is there. I mean, 10 years back, we thought probably, I mean, it's okay. Some things will come out of it. But the ways we see it, shipping as a field, I mean, the way it has integrated in our systems now, it's going pretty fast. To start with it, so let me start with it's going from there. It's going from there or? No. This is the first one.
This is not your, no?
This is mine, but the first one. Start. Yeah. So let's talk about autonomous ships. So that's what we are here for. We have big words like mass, autonomy, all these words that come in. So autonomous technology is that it observes, identifies, interprets, and responds, similar to what we humans do. So what is the difference? Obviously, there is an emotional quotient out of it. So the way it is there, I would come to it. In the past, everyone was like, no, it's not going to happen. I mean, I was that. It's not going to happen in my lifetime, for sure. Maybe a few things, okay, autopilots, track control systems, but autonomous ships, very difficult. 5 years down the line, I changed my thoughts. Okay, it's going pretty fast and probably will come in my lifetime now. But now we have real world examples. There are 2 ships that were built in Cochin shipyard and they are going for trials to Norway. So we are being as a construction hub. No more trials in India started, but I would request Government of India to take initiatives. Inland sector, ferries, these are very easy to do things, which can be done very easily. So one big initiative has to come, one big push has to come from organizations, ship owners. And Again, we are formulating the rules now. We are making rules for the mass code and could be 2025 or depends on the timeline. Now, definition of mass, the standard theory stuff, before I come to the exciting part. So mass, maritime, autonomous surface ships. So mass refers to a ship with varying degree of independent operation with or without human interaction. So complete autonomy versus a part autonomy. So it can be controlled for part autonomous ships. So with the degrees, it's degree 1, ship with automated processes and decision support systems. So seafarers can operate the shipboard equipments and some operations can be automated. Degree 2, remotely controlled ship with seafarers on board at all times. So few things that can be controlled as well and seafarers can take over. Degree 3, remote control operated ships with no seafarers on board. So everything is show-based. And the last one, what we call is ultimate automation. No humans on board. Now, when I was going through this, I mean, these are standard definitions that are coming in. There was a very interesting article when I was researching for this presentation, is this one from 1C. Now, this adds to a pre-automation days as well. So if you see, level 0 is like we all seafarers, all hardwired to being on board, working on the ship, maybe olden times, 18 months at a stretch, 12 months at a stretch, time reduced. So human still controls the vessel. Level 1 was assisted operations, a few of the operations. So what we call it, if you see, hands on, eyes on, mind on. The vessel is moving, but okay, some automation is there just to help you out. Just a finger, not a hand. Level 2, partial automation. Hands off, eyes off at times, and mind on. Right? So maybe an autopilot, could be. Going to level 3, conditional automation. So conditional automation refers to hands off, eyes off at time, but mind on. Track control systems, possible. High automation, level 4, hands off, eyes off, even mind off at times. UMS ships, I can sleep at night, okay, and I can take over when I want. But the last one, hands off, eyes off, mind off, human off. So that's the last one we were talking about, level degree 4. So the humans are out. So a lot of, as Chuck said, a lot of safety systems, control systems have to ensure that. So that is the most important part if you want to go for complete autonomy. Now, what is driving automation? There are drivers, because if it has come up in a big way in last 5 years, definitely there are big drivers to it. There's a big push for it. And it will be interesting to know how and where the push is coming from, which will come from the later slide. So one is the cost, yes. Optimization, as we talked about, autopilots, smart autopilots, optimizations. So you are actually saving on fuel. So research says that probably you save about 22%, conventional versus unmanned. So a business-driven economy driven towards safety, cost savings, a lot of risk assessments have been taken place. Case studies are there already, but still to prove, because more and more real-world examples are happening. And environmental sustainability. That's the most important part. Because that, again, one accident drives the whole thing down. That's the bit. Some practical examples of autonomous. So, a very big LNG carrier, 122,000, sailed from Gulf of Mexico to South Korea, was via Panama Canal in May last year with AI-powered system. And the latter half, the sea leg was autonomous, almost 5,400 nautical miles, was completely autonomous. So that's one good example of a ocean passage. The manning requirements could not be reduced that much. You can come to minimum safe manning what is required. But for international acceptance, I mean, zero automation so far is not possible. It's in national waters, not in international waters. Some of the other examples, research vessel who completed his voyage from Plymouth, UK to Plymouth, Massachusetts, USA. Large passenger ferry operated by MOL, traveled about 780 kilometers in Japan. Japan has taken a lot of initiatives, especially for ferries. And another container ship, again in Tokyo Bay, with a lot of traffic with 500 vessels coming every day. Now, to accept automation, first we have to see what are the challenges to it. So there have been a lot of accidents in the past due to over-reliance on our part, due to over-reliance on ECDIS. But has this stopped technology? No, it didn't. We just plugged the gaps. We plugged the gaps through trainings, we plugged the gaps through better systems, better backups, but technology never stops. And that is a prime example. We talk about ARPA, I mean GPS, let's talk about satellite navigation to ARPA to ECDIS to semi-autonomous to full autonomous systems. Now, challenges. Last session you saw all the technical challenges. Now, I'm going to talk about the challenges for both part automation as well as full automation. Both have their own set of challenges individually. So with human in the loop systems like remote control operations or partly taking over, HMI has to be developed for it like you have handover takeover after a watch. So there will be a handover takeover of auto systems to a manual systems, or shore-based or ship-based, could be anything, depends on the level of degree of automation you're talking about. But the HMIs, human-machine interfaces, have to be very clear. It cannot be complex, it cannot be filled with settings, because, I mean, you will be doing it every day, day in and day out. So the HMI systems have to be pretty clear, the communication protocols have to be clear. Training. Training requirements, the SILK requirements, we all know. A lot of stuff that probably we are learning in different computer engineering or IT field probably has to come in as a part of the curriculum. Situational awareness, decision making. So autonomous technologies can assist humans in gathering lots of data. Now, the data will obviously give rise to a model who will actually be working on board ships. But that decision making, again, if a human is involved, his thought process is different, machine's thought process is different. So the thought processes have to be in synergy. One cannot have completely poles, different, opposite. So you have to understand the model, how it works, especially in dicey situations. In the situations when a human is called, okay, now you take over. There is a sudden situation where it requires your domain knowledge or your operator skills. So that is something. Trust and acceptance will develop over years. So once it's proven, a lot of examples, no accidents, a lot of savings, trust will automatically build in, which will come, for sure. It's going to be a long ride. It's not going to change over instantly. So coexistence definitely will take time, and we have to specially focus on this slide because humans and autonomy will work together for a very long time before everything goes the other way around. Communication and coordination. So the communication need to protocols or whether to communicate with autonomous technologies have to be also in sync. Now let's talk about completely autonomous ships, where we are. Legislation we already know. I mean, so far we talk about humans, seafarers, persons, a lot of regulations, almost 200 regulations that probably I am always digging in, because a couple of regulations are built long back. It could be legal, it could be safety related, SOLAS, human element, lot of things to take into consideration. So safety and reliability, the systems have to be robust, backup, multiple backups, redundancy systems, safety systems, alarm generating systems if a human has to come in the loop. Cyber security, one big challenge. A normal computer, it gets infected with virus, everything shuts down. I mean, you can't expect that. I mean, that's a genuine concern. I mean, when we were saying not in our lifetime, we were saying this only. Come on, a virus comes and the ships goes down. What is this? And you can't do it. But then there are companies who are actually day in and day out making these systems robust and protecting these autonomous vessels, partly, fully autonomous vessels, from cyber attacks. Again, there are backup systems, so things can be easily deployed again. Plan B, what we call. Regulatory frameworks, we already talked about. Legal and liability issues in case of collisions, because still there is some person, there is accountability. Now, who is accountable? A shore-based operator, an autonomous machine creator, a certifying agency. So there's a lot of gray areas still there. The gray has to completely become black or white. I mean, it cannot be gray if the technologies are there. And that's the primary reason why right now, if you see most of the examples, almost 80% is in national waters. All the experiments are taking place in national waters because it's easy to modify the national waters manning requirements as per your requirements. So IMO is working very hard, racing against time to actually work on the international sea-going passages, like we talked about. Because minimum safe manning still exists there. You cannot ignore the minimum safe manning so far, unless there is a definite treaty between, say, Scandinavian countries or some certain countries. That's a different matter. Technological limitations, so relating to weather, congested waters, fishing boats. We'll talk about what will happen to an autonomous ship in China, or maybe Gujarat waters, not very far. So systems have to be tested for these conditions as well. Human-machine interaction, so how to communicate, so that we talked about. Now this is also a very interesting slide. Autonomous systems with autonomous systems work perfectly fine. No problem. Autonomous cars, other autonomous cars, working fine. There's no problems at all. But as I told you, the journey is long. There'll be systems, twin systems will be there for a long time. Now, how to cater to that? That is the biggest challenge, if you ask me. So they are going to operate side by side for a long time. The second part is so-called shore control center. So in shore control center, there'll be people operating multiple ships of the fleet, probably, if they are autonomous. So all their responsibilities, how to operate the manual units, all these legal elements have to come into picture, like we talked about during an accident. Then the last part, which I already talked about, for last 200 years, we have presumed that ship is always manned. It is run by a seafarer like us. So there is nothing called no human on board, like we talked about in the first slide, no human on board. What do you mean by no human on board? How, why, how? A lot of questions come into play. So IMO is, United Nations, IMO, a lot of agencies, GUARD, a lot of these agencies are now coming in to plug this. Skills. So we talked about skills. So if I talk about autonomous levels, the blue guys are us, all our seafarer community. We are the blues. We know how to operate a ship. We know how to go in difficult conditions. We know how to be awake at night in case of congested waters. We know a lot of things. But when complex systems come into play, we probably require some red ones. These red buggers are the IT guys. So like we talked, we had an ETO. So I would love to have an ETO, or for that matter, now whatever the rank, asset manager or a technological officer, whatever they call it, I would love to have someone on board. Because I cannot handle all this, these red guys. So there'll be a clear divide between the red and the blue, for sure, for a long time. Obviously, then our training institutes, government organizations have to step in, make courses, 3-4 years courses, parallel with the traditional stuff that we learn. So those have to come, all these words about control and automation, AI, cloud computing, IoT, all these things have to be in the part of the curriculum. Before, the blue guys partly become the red guys. That is what you see in the later part. So we will develop skills. We will have few IT guys in the background in between. This will go for a long time, the between levels, 3 and 4. But ultimately, we are heading for the last guy who, whether he's ashore, he will have all the skills required. And obviously, ashore, you will have a lot of backup available. So these are skills that have to be developed. If we talk about ashore, so proficiency in interpreting and analyzing data from digital twins. So analyzing advanced knowledge of automation systems, machine learning, data analytics, this has to come in the curriculum. This will definitely come. Familiarity with maritime regulations, us. So even if there is another operator, he has to know what is marine, in case we have kind of asset managers or shore operators. Strong problem solving and decision making abilities. So this is where the humans set in. So, and aboard, in case of partial systems, again, understanding of latest IBS systems and proficiency in using the digital twin, whether for knowledge, for training, and all these algorithms as such. Now, this is a typical ecosystem that will come into play. So the shore operations will also go autonomous. Everything will be communicating with each other. So whether it's cargo operations, machine operations, bridge operations, shore operations, communications, tug operations, could be, some of it could be part autonomous, some it could be complete autonomous, some it could be human related, but they have to interact with each other. These are the major changes will happen in the industry, all the sectors, whether it's cruise, tourism, how to handle search and rescue, environmental protection, fishing, probably fishing, they have to understand how to interact with the autonomous vessel. So all these sectors will change. There definitely will be definite, probably traffic lanes and implementation of those lanes. Let's see how it goes. So ashore, probably you will have a kind of a digital dashboard whereby all the weather forecasting, all these services will come into play. Our operator will take charge of a vessel, and then he's automatically setting up and controlling a digital twin. So all these automation systems will come there, and that also can be used as a training tool as well. So that's the benefit. So you have people on the shore side, you have people operating the vessels, autonomous vessels, and training, all going hand in hand. So AI, we talk a lot about AI. Artificial intelligence, yes, artificial, yes. So all the data that is fed is creating models, but the way the whole industry is lacking is sharing of data. Everyone is trying to make an own AI model and trying to be superior. Okay. Imagine if nowadays there are platforms whereby these data is available, limited though, but I would say the next step in the industry is to share data. You talk, data is the new fuel. Everyone is sharing their fuel in their jerry cans. Nobody is sharing anything. So that's a problem. Because, just to give you an example, if you are passing Singapore Straits, I need to have a data of at least 2,000 ships that have passed through 1 fathom bank. At that course, at that time, at that tide conditions, at that current conditions, and that season. So imagine how many combinations you have. You will have millions and trillions of data that you require to create a good AI model, which we don't have. You're giving fleet optimization to a company whose 1 ship is going in a month, or probably 3 ships are going in a month. So that's the data that you have. Imagine integrating all of them. You can open a world map and see how many ships pass through 1 fathom bank. Imagine that data at any given point of time to make an AI model. It will be very robust. That is what is required by the industry. There are a couple of, like you said, open source available. So open source community is there stepping in, but then again, many other regulations do not allow people to share data with each other. Digital twins, as we said, so there is a replica created of a vessel which can be used for automation, which can be used for training. So a lot of different things that you can do with that. Now the most important topic which Captain Kishore talked about, vendor neutral IBS systems. Now what is vendor neutral IBS system? That's very interesting. So what we are talking about is how that traditional bridge systems were isolated, fragmented, they had their own data, they were working on their own. So imagine two autonomous ships coming. If one is connected to the other, and if one is taking action, see, ROR model obviously will be there, but you also know, I also know, there are situations like shallow patches, traffic, which do allow us to deviate from those rules, either in agreement or otherwise. So if these two autonomous vessels are communicating with each other, life will be very simple. One is taking action, the other is taking counter action. That's it. As simple as that. It's just communicating between two. So that's the challenge where human and autonomous will come into picture. So we need to design IBS systems, whether traditional or fully autonomous, to actually talk to each other. So that whole thing is transmitted, okay? This is the intent of the autonomous vessel to pass green to green, not red to red. So I'm also very clear now, because I'm not communicating with anyone. There's no person on the bridge whom to communicate. So vendor neutral IBS systems are there's one platform called Veracity by DNV, there's one Autonomous Shipping Alliance. There's a lot of companies doing that. But I guess we all have to come in a common platform. We need to have same seamless communication and data sharing protocols. We need to support advanced automation, autonomy, and obviously the digital twins, like I talked about, can be used for many things. Training, live simulation, live action as well. Now coming to the Maritime Training Institutes. So digital MTIs have to come into play. What are digital MTIs? So there are a lot of examples where air traffic controls is on the top floor, and one floor below you have training establishment. So that's interesting. They are getting exposed to the real world. So that is where now digital MTIs have to come into play, whereby the digital MTIs are very close, or at least getting the feed from the real data, so that the trainers can actually get hold of the real world conditions. This is a couple of R&D that we are doing as such. One such example is digital dashboard that you're seeing, augmented views, digital versus simulated. So all these things are there. We are already engaged into it. We are also analyzing behavior of 3 different operators, how each will behave to create a better AI model for a better prediction. So if you see, this is a prediction model for the autonomous vessels where everyone is going as per path, and if someone deviates, the other one is actually taking counteraction. And the last slide is particularly important because when you have an operator watching the screen of the vessel from a CCTV view, he doesn't get the holistic view of obviously as an operator, yes, as a seafarer, probably you'll be able to, yes. There may be people who may not be seafarers, probably in the future. So we need to create systems whereby a whole 3D holistic view is created from AIS, from the area in question, from weather forecasting services, from the different systems to create blended views or fusion views, so that at any point of time you are getting a bird's eye view of what is happening and what you're supposed to do. So this could be one of the views that can come once the autonomous systems come into play. So that's where I wind up, and thanks again to CMMI for giving the opportunity, and let's see more technological advances ahead. Thank you.
Thank you, Gaurav. Excellent, I should say. Few things just to tell you that yes, platforms are available. Cognify for one. Captain Yanki Sharma is aware of Masterly, which is a collaboration between Consberg and Williamson. A lot of things are available where you can have an analytical engine playing on top, no doubt about that. What he said about the legalities of the particular place in question, like today, we are able to operate autonomous vessels in the Norwegian waters or Setonaka in the inland sea, Japan, because the local administration does that. Many administration may refuse to have any kind of automated vessels coming into their waters, and that is bound to happen. Example could be Concorde. Concorde flew for quite a number of years, but many countries did not allow Concorde to fly through. Whatever reasons, because our glasses were not good enough to take the, the sound vibrations that would come and break the glasses or whatnot. That is, though it's an example in parlance, but Concorde vanished. Autonomous vessel is not going to vanish because we will find a solution to that, and there will be solution. One of the major ones, again, to remember is this Mars 4 degrees can be in a single voyage. So a ship owner can easily crew up the vessel just before you enter such waters which doesn't allow autonomy. And let him sell autonomous, like that vessel which sailed for 7,000 nautical miles, totally autonomous. That is very much possible. He talked about cyber security, which is so true. As a matter of fact, AIS, as we know, is just line of sight. But there is a technology, Sintef is a body in Norway which works on all R&D works. And Kongsberg has been a partner with Sintef both on the aerospace as well as oil and gas as well as maritime industry. One of the things being worked on is satellite AIS, which increases the range to about 400 kilometers easily. But then every single aspect of these kind of technology changes, as exactly Gaurav pointed out, they always go through something called as a hackathon. The hackers of this world, the ethical hackers of this world, are called to do something, hack this system. And I'm talking about just about 9 or 10 months back, one of the hackers put a US submarine, nuclear submarine in Crimean Sea. Just imagine if it had been done live in this present situation with Russia and Ukraine. It would have created an absolute ruckus. So again, it has gone back to the dashboard. They have started working again on the systems. So cyber security is an issue that can happen. With this, gentlemen, open for questions, possibly another 5 minutes, Captain Pradhan. Another 5 or 10 minutes, we can take questions with both the speakers, please. No questions means only two things. You understood everybody or understood nothing. So, has to be some.
Yeah, I'm Captain Dubey from MMTI. My question to Mr. Gaurav. First of all, I must say that it's a good presentation, very well presented. My question is that when we're talking about the mass, are you talking about pilot to pilot, or we are talking about pilot to berth or berth to berth? Or is it going to cover up that portion also, where the narrow channel and canals and harbor areas are concerned? Thank you.
Thank you, sir. Yes, so that is what I was talking about initially, that the national regulations can be changed easily to adapt to this. Many countries have started remote piloting. So one is that probably an IT guy boards the vessel and does the remote piloting. The piloting is done from ashore. So one is that concept. International waters, minimum safe manning requirements is there. So actually you cannot make it zero, completely autonomous. Right now, world navigation is not possible. So you can divide the voyage into steps, like we talked about in that LNG vessel. So Panama Canal Transit, people were there. For the sea leg, autonomy was there, people to take over. So what we talk about degrees, the 4 degrees still not possible right now in international waters. In national waters, the countries which have actually done it, like Norway, Finland, there are a lot of countries which have actually allowed it, Japan. there is complete autonomy, right from birth to birth. So there, and this, the most easily implemented systems are inland waterways, ferries, all these can be completely automated. So these are the traditional cases, and for the big ones, IMO, after the mass code, then probably will come into the international voyages once the legal aspects are taken care of. I probably I answered your question. Thank you.
Good morning, sir. Thank you so much for this wonderful presentation. My name is Philip. I just want to know, well, according to me, degree 1, degree 2 would come in. But what time span would you give to degree 3, degree 4? And my second query is, will the disciplines on the ship, traditionally being engineering, nautical, continue to exist as it is today? Or are we tending something towards integrated or polyvalency as it was called some time back? And the skill sets would be very much different. What we are undergoing today may not exist. And third thing, which I have another doubt is, of course, the ROR will have to undergo a big change, and I think studies are already on. But what happens to the ISPS aspect with these things? Thank you so much.
Thank you, Philip. I think I will take the liberty of...
Maybe you can use this one in the meantime.
Yeah, thank you, Philip. I'll take the liberty of answering your... Starting from one. A typical scenario would be a shipowner possibly... As a matter of fact, any IBS system today, with a little bit of changes, can get a autonomous vessel notation, for example, once we come up with the regulation. Once you get the notation, a shipowner has got a choice to choose his level of automation along the passage. Probably a shipowner will choose to say that I will have the deck complement joining in with the pilot. That means I will go into a degree 2 or degree 1 automation at that point of time. Take the vessel in, finish your cargo work, come out, you are still on a degree 1 or 2, come out and get this guys out, go into a degree 2 where you have some manning on board. Maybe, you may have 3 or 4 watchkeepers at the most. You may not even need engineers, fitters and seafarers to maintain the vessel, seamen to maintain the vessel. I'm just thinking far and ahead. Let the vessel go either with these crew, a little bit of crew, or with none at all along the sea passage and repeat the same thing on the other side. That's very much possible. That's number one. Your number 2 question, yes, I think tomorrow's seafarers could be a general manager with 4 or 5 watchkeepers. It could be a third engineer who skills himself up to be a navigator and a remote operator, or it could be a second officer who could do the same. It could be both. There are so many avenues by which we can bridge this gap. We don't need celestial navigation and know what is time and know the kind of teaching that we have. Our syllabus possibly need to change to attune ourselves toward having a set of managers to manage the ship, just 3 or 4, and the rest to maintain the ship. Or maybe they may even go for every year dry docking, so that all the maintenance is done in dry docking and let the vessel sail for years to come. Lot of subsets could happen. But training towards that is the game of today. I think we need to understand what needs to be skilled up. I would say that we should create super users as a country. Which way we create, which path we create, I don't know. But we should have super users who can both navigate the ship, could be these guys from ashore, as well as stay in a remote operation center and navigate. Does that answer your question, Philip? Somewhat.
Hi. I've got a question for Vaishak, just so that he doesn't feel lonely. Vaishak, you're generally the technical guy, and you're dealing with all the mariners in the organization. And yeah, to some extent, people would crucify me for saying this, but we are kind of dinosaurs in this. We prefer the age-old things. There are a lot of mindset challenges, I guess, when you're kind of trying to put things across and get things changing. So your thoughts on those, because finally it's a mindset change from everybody in the chain to take things forward, embrace it. Half the people say, not in my lifetime, not in the next this thing, whereas some are very positive thinking and, flowing with it. So your thoughts on this, because I think that's going to be a huge challenge in us going forward as a nation?
Yeah, thanks, Hari. I was really feeling out of place here, but talk about jargon. But yes, I agree with you. You have different mindsets. I remember myself when proposing these vague ideas out at sea, maybe some 20 years back. They looked at me as a weirdo. But these things will go through no matter what, right? People's opinions will adapt, they will change, but technology ain't stopping for nobody. So there is no two ways that things will change. What bothers me perhaps the most today is the fact that we're kind of shackled into training our seafarers, technical as well as the navigation people, both of them, in a templated format. Now, I do believe that needs to change primarily to change the mindset. So if that doesn't open up, that's going to be a problem. And I think Gaurav, you suggested some possibilities thereof. So, yes, please.
Yeah, good morning. This is Captain Kraning Ray here. Actually, I have a little concern with respect to maritime cyber security. As everybody is aware of this, nowadays on date, if there is a small issue with EGDIS, people are unable to solve and sometimes they put ship in danger. So how much research is being done by the ship owners or by the shipping companies or by IMO to adopt these mass ships? It is only a code which is coming, or it is one-sided, or it is everybody interested to go on that. That is what, if there is any statistics or data that you would like to know.
Yeah, thank you for your question, actually. I'll answer part of that and then I'll pass it on to Captain Kishore or perhaps Gaurav here. You're right. We have a huge problem when it comes to different standards and possibilities. Cybersecurity is huge. It can stall things. It can bring you to a crawl. It can hold your ship hostage. So there's a big problem. But we are beginning to see mechanisms being deployed that permit controls, if you will, to be activated at just the right stage. So there is a pro and there's a con to this. This allows for better management of that system. It allows for remote dial-in possibilities, like I mentioned. But it also brings in the problem that vendors will tend to hog certain key aspects of that network. It's a way of maneuvering their monopoly into the system. And that is where, things like what he was saying matters, where we can share information on a common system. So that's one way, one work around it. But yes, I do accept the point of cybersecurity, and it's extremely important to be, educated and aware of that fact. You want to add anything? No, I think that's all.
Yeah, it's a very valid question, Captain Panagari. Cybersecurity-wise, yes, he said a lot of, one of our own sponsors, Station.com, I don't know if Anshul is here, they're also providing, as I said, vendors providing solutions. But the advantage of this digital platforms is like railway platforms. Any application can go and sit there. It's like a marketplace. But the digital platform ensures that it is a fully researched and fully safe system till somebody hacks it. Always remember that. When somebody hacks it, then you go about again doing the same thing. That risk will remain. And that's where the risk management towards implementing the MAS is also equally happening as we speak. I think...
Hi. Please. I'm Captain Gaurav Rana. I run Sea and Beyond. So we are partnered to about 100 odd companies for their shore job needs. We are also partnered to a few universities in Europe which provide courses for mariners or for the shipping guys. My question here is, and this is more focused on the skills which are required to work in a shore. Are there any courses? So the first question is, what are the typical skills which are required for a mariner to work ashore? And more shipping companies are looking for, people who are not just, skilled in navigation or engineering, but know bit more on the technology side. So what are the skills required? B, are there any courses? Is there a way for a person to, more specifically for a mariner, to upskill and, smoothly transition ashore in various new jobs which are coming through?
Yeah, okay. So I think that's open to both of us here. Thank you for that. Skills required, hard to put it into boxes, really speaking, because I think it's a continuous process at this stage. But I definitely think dabbling in technology in general is pretty much what's required and on the radar for both these streams, engineering, navigation, has to happen. Like I said earlier, I find a big gap there. Are there dedicated courses for this? Well, the answer is yes and no. Yes, because these courses do exist, but they, like they say, they have many engineering disciplines, but out at sea, it's a problem. It doesn't really care what kind of a problem it is. So there are courses that are designed to understand this, but they elaborate and they are not customized. You want more custom approaches, so I think the online portals offer you short-term courses which can quickly upskill and help you, or at least increase your awareness and then make an educated guess or a choice there. But yes, these courses do exist. I would talk about data science, I would talk about networking, and I would talk about engineering in general, but applied to information technology, how engineering and information technology synergize. So these are the three contributions from my side. I'll just pass that on to Gaurav for the next.
Yes, partly it was answered by Hashak that courses do exist. I myself did an advanced diploma in artificial intelligence online. But the main issue with this is that nobody is focused to shipping industry as such. It is focused on a subject. Data science, edge computing, artificial intelligence, everything is available. And these are short courses. There's like not very complex ones. There are even longer ones as well. The issue is this has to come from way below. It has to come from university level. Correct.
No, yes, last question, please.
Answered. Thank you.
Answered.
Just please stay on the say. Sasi Kumar, can we have the plates?
I think Vaishak answered that, Philip.
Can we have those things?
We will be re-skilled to be used the same way. I think we will still have the edge as long as we become super users. We just have to move with the times. We have to accept. If you're sitting in, in an archaic world, you will be left behind. But people like you and me are not going to make that happen, isn't it?
Thank you. I just have our chairman of the session, plaque for Mr. Vishak first. Stay on the center so the people can take. Plaque for Captain Gaurav Bajaj. May I request our Deputy Master, Captain Pradhan, for a plaque to our chairman, Captain Kishore. And a group photo now. No, I will come in the end. No, I'm in the side. The speakers are there. Thank you. Now we move on to our much awaited tea. So we break for a tea session. We'll be starting back at noon, 1200 hours. Thank you.